Hello everyone, my name is Kunal and I am your physics tutor, and we are actually doing simple harmonic motions, and today is our third lecture on simple harmonic motions. So let's start our today's lecture. So today is our third lecture on simple harmonic motions. So let me recap the things कि हमने क्या क्या चीजें cover करी थी. So in first class we actually deal with some time period. We are actually familiar with omega, which is actually known as angular frequency, and then we derive the, and then in second lecture we derive the all equations of or related to SHM, such as like we are actually starting with we have a known equations for simple harmonic motion. We all know that force is equal to that minus of kx. That means force is linearly dependent on the displacement from the mean positions, right? And then we derive the all of the equations like v as a function of x, a as a function of x, and all, right? And then we also derive some function of time as well. Okay, so we reach to the conclusion like the energy is total energy is independent of the time and the mean position. It's always conserved and its value is actually equal to half of a square, right? So this is the thing that we actually know. So in today's class, we are actually gonna deal with some the things which is actually we are written in the previous lecture. Like let me write it y or x. So we are writing as a y is equal to a sine omega t plus phi, where I am calling it as phase, which I am already told you that I will be discussing in the next class. And the phi value is actually nothing but sine inverse of x y naught by a, right? Where y naught is the position of the particle at the time t is equal to 0, right? So in today's lecture, we are actually dealing with the these phase term and what its meaning, and meaning तो मैं पिछले क्लास में बता दिया था. So let's start our today's topic, which is actually phase and phasor diagram. Okay. So what did actually the phase of a SHM? Let me write it here. Phase of SHM is whenever we write these terms like omega t plus phi, omega t plus phi is actually called as our phase, or it is simple an angle, so we can call it as del. Okay, we call it as delta. Now, what is actually phase? So our phase determines the state of motion. What is actually phase? So phase determines our the state of the motion. Like phi is our actually initial phase, and with time our phase vary. That means that determines the state of the motion. ठीक है, ये आपको वही बता रहा है कि किस टाइम पे कितनी एम्पलीट्यूड्स हैं, किस टाइम पे कितना एक्सेलरेशन है. एनर्जी विल बी कांस्टेंट. Overall total energy will be constant, which is actually equal to half of k square. So this is actually independent of phase. Total energy is actually independent of phase, but rest of the things like acceleration, velocities, and kinetic energy, potential energy, these all are varying with as phase varies, right? That means as angle changes, its state of motion changes, right? And what is phi? So phi is our initial phase, which is phase at t is equal to 0. Basically, phase is nothing. It just determines the states of the motion, right? I hope you'll all understand what I'm trying to say. So let me, if you didn't get, let me take an example, basic example, so you can uh, understand in well manner. So let me take the displacement as a function of time. So it will be like we already derived it. Our particle actually doing simple harmonic motion in x-axis because we are taking x is equal to a sine omega t plus phi, or we can write this as a sine del, right? Where del is just the phase difference, okay? Sorry, del is just the phase. Now, what I'm gonna take it here is, let's take uh, del is equal to 30 degree. Okay, let's take del is equal to 30 degree. So when I take the value of del is 30 degrees, so our x is nothing but a sine 30 degrees. So its value will be nothing but plus a by 2, right? And when I have to find the velocity at del is equal to 30 degrees, so what I'm just doing, we have to find just x dash, which is actually equal to v dx by dt, and it is actually equal to a omega cos del, right? And the value of omega will be something. So what I'm gonna do here is, our del is given, so our velocity is nothing but a omega cos 30 degree. And we all know that the cos 30 degree value is nothing but a omega root 3 by. Okay. So if someone told you like, show me the states of the motion. Okay, show me the state of the motion at del is equal to 30 degrees. So what you have to do, you have to just draw x-axis here because our particle is actually uh, doing simple harmonic motion on x-axis. So this is our x-axis, and this is our actually y-axis. So no need to show the y-axis. It's just show the x-axis because nothing is in y direction. Okay, so our particle is something like here. If I am assuming origin as a mean position, and I am saying if particle is going from plus a to minus a, this is our mean position, and like this particle is our doing simple harmonic motion. Okay, so at the some angle which is at 30 degree, so it's an actually positive direction. So I'm just considering there the a by 2, and our velocity is also in positive direction. So our particle is actually going in this direction, with velocity actually is equal to a omega root 3 by 2, and there is the particle, and at that moment the velocity of the particle is actually a omega root 3 by 2, and here the phase difference, actually here the phase is here the phase is actually 30 degrees. I hope it will be clear to all of you, right? uh, Now let's take its reverse. Okay, so let me take the next example so you can reversibly connect it, right? So here, like x is given as a function of something like omega t plus phi, and here the del is given, right? So now you have to find like what is the value of the del, and here actually x is equal to given a root 3 by 2, and you have to find the value of del and v. Okay, so what you have to do, look at here. Our x is actually actually in the form of a sine omega t plus phi, right? So this is our actually del. So our x is actually given a root 3 by 2 a sine del. So this will get cancelled, and we all know that del is equal to sine inverse of root 3 by 2, which is actually is equal to pi by 3. That means 60 degrees. So we actually get the value of del. Del is equal to 60 degrees. Now the next thing that we have to find is value of velocity. So we all know that the velocity is actually, if our x is this, our velocity is a omega cos del. So we actually didn't know the value of omega, so we have to just go through the uh, del value, right? So it will be equal to a omega cos 60 degree, and it will be actually is equal to uh, a omega by 2. But there is a thing, is the pi by 3 is the only value at which sine value is root 3 by 2. There is one more value, right? If I am talking about in the range of 0 to 2 pi, so there is two value at which the sine value is root 3 by 2. One is 60 degree and one is 120 degree. That means one is pi by 3 and other one is 2 pi by 3. So here it may be del value, may be two values. Look what I'm trying to say. If you go to the coordinate system, so in this, all trigonometric ratios are positive. In this, sine is positive. In this, tangent is positive, and in this, cos is positive. So what I'm trying to say is ki in this and in this region, sine value will be positive. And here what we have to do, we have to find the value of delta for which sine value of delta for which its value will be equal to root 3 by 2. So we have actually two value, pi by 3 and 2 pi by 3. So the second value will be one of more value will be 2 pi by 3. So for for del is equal to pi by 3. For del is equal to 2 pi by 3. Our V is actually equal to A omega cos 2 pi by 3. And in this region, cos is negative, so it will be equal to minus A omega by 2. So, and now you have to show the state of motion there. So there will be two cases. If del is equal to, let me, okay. So what I'm doing here, for del is equal to pi by 3, our state of motion is something look at here. This is our main position. This is our minus A, this is our plus A, let me call it as. And we are actually root 3A by 2 forward, right? So we are actually here and this distance is actually our root 3A by 2. And we are actually going in positive direction with velocity is equal to A omega by 2. Now for del is equal to 2 pi by 3. And it is something look like this. This is our main position. This is our minus A and this is our plus A. And in this case, our del value is actually actually 2 pi by 3. And so it will be actually is equal to root 3A by T. But our velocity direction is actually minus omega by 2. So we are at actually same position. But this time our direction of velocity is in opposite direction and it is actually is equal to minus A omega by 2. I hope this will be clear to all of you. Right. So these are the our state of motion and why and with the help of phase we can determine the state of the motion. So state of motion. I hope it will be clear to all of you. Now I'm gonna draw a figure which is actually representing the phase of different positions. So let me draw it here. Phase of different positions. Okay. I think it is fine. This is our actually minus A. This is our actually plus A. And this is our actually, let me call it as, I hope this will be not fine, but okay. This is our main position. That means this is our at x is equal to, at t is equal to 0, x is equal to 0. Okay. So what I have to do here is key. This is our actually A by 2. This is our actually A by root 2. This is actually our root 3A by 2. And this is our A. Okay. Let me draw one more this thing so I can connect it with you. Second, and I'm just drawing for one cycle. Okay, let me clear here. For one, actually one complete cycle. Okay. And I have to draw one more. So, okay. Now, we all know that our x is equal to A sine del, where del is actually equal to omega t plus phi. You know? And phi is our initial phase and del is our phase, basically phase. So what I'm trying to do here is at x is equal to A by 2, the value of del is Actually, now I'm trying to do here is the value of del 0, 30 degree, 45, 60, and will be 90. In this position, particle is going in this direction. Our velocity direction is this. Now next, this is our actually main position, and at same position below, same position below, same position below. The value is actually 120 degree, and this time our particle is going in left direction, 135, 150 degree, and there is our value not zero. Their del value is actually 180 degree. Same as 210, 225 degree, and here will be like 240 degree, and there will be 270 degree. Now next, here just below it, it will be 300 degree, it will be 315 degree, it will be 330 degree, and the same 360 degree. So this is actually one cycle. This is actually T is equal to T. One complete cycle. Okay. So this is the things that I am trying to show. When our phase is varying from 0 to 90, our velocity is positive and our uh, particle is moving right toward the mean position. When our phase is varying from actually 90 to 270 degree, so our particle is actually moving in left direction. It will be clear to all of you through this figure. And when our phase difference is varying from 270 to 360 degree, that means for one complete cycle, so our particle is actually moving in right direction. So let me show it here. So if you look at here, what I'm trying to do, I just start from this point. I start moving here, and I start moving from here to here. And then I again reach to that point. So this is the thing that one complete cycle I'm trying to show you. This is the actually state of motions. Velocity की मैं ये बनाया हूँ. This is actually the how particle moves. Okay, or directions of velocity for in one complete cycle. I hope you'll all understand what I'm trying to show. Okay, first it goes to the right direction, and from here to here our phase difference is 90, and from here in second line our phase is actually 90 to 270, and in third line our phase is varying from 270 to 360. Okay, so keep this thing in mind, and let's do some problem based on it so it will be clear to all of you. So let's do some problem based on it. Actually, you have to write the equation of simple harmonic motion whose amplitude and angular frequency is given and state of motion is given, right? That means the figure is given. So, question. You have to actually write equations of simple harmonic motion whose amplitude is equal to A, angular frequency is actually given omega, and some state of motion is given, right? So you have to write the equation. So this is our actually mean position. At t is equal to 0, x is equal to 0, and our particle is at here. Let me call, and this dark point showing our where is the particle, right? In first case, our particle is, let me take the first case as simple. So there is our actually, and there is our particle. Let me do with the dark spot. Okay. So you have to write the equations of the motion in second. It's something like this. And this time is our obviously mean position. T is equal to 0. x is equal to 0. And at that time, actually, let me draw. It's actually in this direction. Our particle is at same place, but this time the velocity direction is in opposite direction. Third, this is our mean position. And actually, x is equal to 0. But this time, these are actually plus a. Let me write it here, obviously. Minus a, minus a, minus a. But at this time, at t is equal to 0, our particle is at that position. And okay. And the next thing is fourth question. Let me take it to the 5 question so it will be clear to all of you. This is our actually mean position at x is equal to 0. And in this direction, our velocity at x is equal to a by 2, a minus a. At t is equal to 0, our particle is at x is equal to a by 2. That means that is our initial phase. This is the actually variation in our initial phase, not in total phase. Total phase is del, initial phase is phi, right? So there is a change in initial phase. Okay, now let's take the next question. Fifth. Okay, so let me take it in a good way. So this is our mean position. X is equal to 0. And in this time, our particle is at here something. I'm going like minus a root 3 by 2 and t is equal to 0. Okay, so actually you have to write the each and every uh, equations, state of motion equations, right? Okay, so let's start with the first one. So in this question, we have to actually look at the state of motion, right? And try to compare it with this one. At 0, our particle is going, and try to memorize it with this figure. Okay, so in this question, actually the normal equation of the motion is x is equal to a sine omega t plus phi, where omega t plus phi is our actually phase and phi is our initial phase, right? So initially the particle is at t is equal to 0, x is equal to 0, so its value actually is equal to 0, right? So the initial phase is 0. So our equations of motion is nothing but x is equal to a sine omega t plus 0. That means a sine omega t. In this question, actually, it is merging with the 180-degree angle, right? So our initial phase is actually phi. So in this case, our x is equal to a sine omega t plus phi. And this actually is equal to minus a sine omega t. So this is our equations of motions. In third case, our particle is at actually pi by 2. So our initial phase is, that means initial phase phi is equal to actually 90-degree. Why? Because look at here, right? It is actually del is equal to 90 when the particle is going in right direction, and it will act in the end. So it will be actually is equal to x is equal to a sine omega t plus pi by 2. It will be equal to a cos omega t. Now let's move to the next question. At a by 2, let me correct, actually let me find it out. So we all know that x is equal to a sine del, and here the x is equal to a by 2. So it will be, so the value of del is nothing but 30-degree, right? So here the initial phase is our actually 30-degree, right? Because net phase is actually varying due to initial phase. And at t is equal to 0, it is at x is equal to a by 2. So our initial phase is actually 30 degrees. So it will be actually equal to x is equal to a sine omega t plus phi, which is here actually 30 degrees. Now let's move to the next question. And this one is at, let me try to find it out, right? There's actually in this figure, two things is given. One, the direction of the velocity, and the next thing is the value at t is equal to 0, right? That actually that means initial phase difference we can calculate. So let me write it here. We all know that x is equal to a sine del, and at the value of it will be minus a root 3 by 2. So it will be actually equal to, and one more thing, there's the velocity is in positive direction. So it will be calculated as 300 degree, right? So our x is equal to here, because at 300 degree, its value will be minus root 3 by 2 and the velocity is actually positive. Why I'm saying that? Because in fourth coordinate, if you take the derivative of this, you will get a omega cos del. And in fourth quadrant, that means from 270 to 360, the value of cos is positive. And since our velocity is in positive direction, so it will be counted as a positive manner, right? So our del is 300 and our equation is a sine omega t plus 300 degree. I hope it will be clear to all of you, right? So this is an actually easy question. You have nothing to do, just related to the phase of different positions, right? Now, let me give you another questions, which is actually based on uh, this above concept and whatever we already read. Okay. So let me write it here. Okay. So our question is question 2. A particle of mass 1 kg is executing a simple harmonic motion on a straight line under force F is equal to 8 minus 2x. If particle is released at, let me write it here, if particle is released at x is equal to 6 meter at the time t is equal to 0, then you have to write the equation of simple harmonic motions. Okay. So look at here. First thing is given, like mass is given, and we actually know that our particle is doing executing SHM simple harmonic motion, and this is our actually force. But this force is actually not our of favorable kind. F is equal to minus of kx, in which the mean position at x is equal to 0, right? Where the net force is 0, right? But at in this question, our mean position is not x is equal to 0. Our mean position is somewhere else, which is where the value of the force is net force is 0. We will calculate it later. First, try to understand the question. If particle is released at x is equal to 6 meter, right, then write the equations of the motions. Okay. So let me try to draw it here. Actually, this is the straight line where our particle is executing SHM. Okay. So this is the straight line where our particle is actually executing SHM. Now the thing is we have to calculate the mean position, and we all know that the mean position is where the net force is 0. So we have to do like 8 minus 2x is equal to 0. So x is equal to, we get 4. So let me try to write x, this is actually x is equal to 0, and this is actually x is equal to 4. So this is our actually mean position, right? And the particle is released at x is equal to 6 meter. Okay, and the particle is actually released at x is equal to somewhere here, 6 meter. Here the t is equal to 0. Okay. So there is some change in phase. Actually, there is some initial phase, because our phi is here not 0, right? So let me write it here, the equations of the motion. So the equations of motion is uh, this is actually our plus a. So at x is equal to 2, our minus a, because our amplitude is actually 2, right? So our amplitude is nothing but 6 minus 4 is equal to 2 meter. Okay, because where the particle is at at its initial time, and where is the mean position, the difference between those values will give us the amplitude, right? So here the amplitude is actually 6 minus 4, which is actually is equal to 2 meter. So now we have to write the equations of the motions. So what we have to find, x is equal to a sine omega t plus 5. We have to find the each and everything. So we are actually calculated the value of a, which is actually is equal to 2 meters. Now the next thing we have to find is omega and phi. So how we calculate the value of omega? Our mass is actually here given, right? Actually mass is given, and if we compare this to f minus kx, so our k is given, which is actually equal to 2. And we all know that the omega square is equal to nothing but k by m. So here we'll get omega is equal to root under k by m. And omega is actually mass is 1 and k is 2. So our omega is root 2. One more thing we get. We get a, we get omega, and now we have to find the value of the phase, which is actually because at the t is equal to 0, it is not at x is equal to 4. That means at its initial time, it is the particle is not at mean position. It is at somewhere else, or like it is at x is equal to 6 meter, which is actually not our mean position. So there is some initial phase. So we have to calculate that phase, right? And which is actually is equal to phi is equal to 90, because our particle is at extreme. And when the particle is at extreme on the right hand side of the mean position, so if we are going through this figure, so it will be actually equal to 90 degree. So here the phase is actually our 90 degree, right? So let me write it here. Our phase is actually is equal to 90. So here we get phi value also. And one more thing, our particle is actually 4 meter away from the mean position. So if I am going to write here, we have to write like 4 plus our a value is 2 sine omega value will be root 2 t, and plus phase difference will be 90 degree. So this is our actually equations of motions that we are talking about, right? So this is actually the equations of motions. X is equal to 4 plus 2 sine root 2t plus 90 degree, right? So if somewhere you have to find the equations of motion, then you have to find a, omega and phi. Okay, so we actually you have to deal like in this way. I hope it will be clear to all of you. Now let's move to the next topic, which is actually termed as phase difference due to time difference. Let me give here the heading, phase difference due to time difference. Like we are talking about the initial phase, right? Like at t is equal to 0, particle is somewhere else. It is not at mean position. So this is our actually initial phase. But what if I am talking about uh, two times, like at time t is equal to t and at time t is equal to t dash. So they are both at both position, particle is at different value of x. The particle have different positions. So the particle have different phase. So what we have to calculate? We have to calculate the phase difference due to time difference. So let me write the equation so it will be clear to all of you. Don't worry. So our basic equation of the simple harmonic motion is x is equal to a sine omega t plus phi, where phi is our initial phase difference, right? What I'm talking about, let me take the time t is equal to t initial, right? So we can write this as a sine del. So here our del initial will be nothing but omega t initial plus phi, because initial phase is same for both, right? This initial phase is same for the whole value. Why? Because initially there has a phase difference phi, right? It is not for the whole system. It is not considering for the whole motions. We are just considering that initially our phase difference is, if I'm talking about in the phase of angle, so it will be 90 degree, and it will remain for the whole motion, right? It will never changes like initially our phase difference is something and in next time our phase difference will be different. No, If our initial phase difference is phi, so it will remain same for the whole motion. Okay. So this is for time t is equal to t initial, and for t is equal to t final, our phase will be del final, and it is actually equal to omega t final plus phi. Initial phase will be same. Initial phase phi will remain same. So, but initial phase will be same, remain same, but there is a phase difference, right? Due to omega into t times. We are taking two different t, so our if I am taking here the del, uh, so what I'm doing here is like del f minus del initial, right? So it will be actually equal to del. Let me write it here. So when we subtract equation 2, let me take out equation 2, let me take out equation number 1. So if I subtract equation 1 from equation 2, so what we'll get? Omega t final minus t initial. So here we'll get del is equal to omega. It is actually del t. And here we will get del change in phase difference due to change in uh, basically phase difference due to time difference. And omega we can write it as 2 pi by time period into delta t. So this is our thing. This is actually important formula that you have to keep in. I hope it will be clear to all of you what I am talking about. If phase difference due to time difference. Okay. So we all know that the simple harmonic motion equation will be a sin omega t plus phi. So we are actually talking about two times, which is actually t initial and t final. Here the initial phase difference is same for both, right? Any motion we are considering, our initial phase difference will be remain same, which is actually equal to phi. Now what I'm trying to do here is we have to, I am actually calculating the phase difference due to time difference. So what I'm trying to do is just subtract the equation 1 from equation 2. So when I do so, what I get like delta del is equal to omega t final minus t initial. So what we, in finally I get phase difference is equal to 2 pi by time period. Let me write it here. Our t is here is actually time period. So it is actually equal to 2 pi by time period into uh, delta t. Right. I hope it will be clear to all of you what I'm trying to say. Okay. Let's take the one example. So this is actually the whole concept of the phase and all, right? Important concept. So let me take here the question. A particle executes SHM with time period t is equal to 4 seconds. Find the time taken by particle to go from first mean position to half of maximum amplitude. Look at here. This is actually our question, right? So what you have to find the time taken by the particle to go from here to here. Look at here. We are actually try to find it here. The where is the, okay. In this cycle, we are actually trying to find the phase angle, right? At a by 2, our del is 30 degree and all. बट राइट नाउ वी आर ट्राइंग टू फाइंड कि कितने समय में ये मीन पोजीशन से ए बाई 2 तक पहुंचा, लाइक कितने समय में मेरे पार्टिकल ने, जो भी पार्टिकल है उसने एम्पलीट्यूड की आधा डिस्टेंस कवर करी है. ठीक है. सो दिस इज द थिंग दैट वी हैव टू कैलकुलेट. So we are actually simply here derive an equations. We are actually know the phase difference due to time difference, right? So if I have to calculate the from mean position to the half of the amplitude, so our 0 to a by 2, right? So our phase difference is our here is at 0 it will be 0 and at a it will be equal to 30 degrees. So pi by 6. How are I calculating this? We all know that x is equal to a sine del, and at when x is 0, so our del is 0. And when x is actually a by 2, so our del is nothing but pi by 6. So overall the phase difference is actually delta 6. Now we have to calculate the change in time. So at t is equal to 0, I'm assuming that our particle is at mean position. So what I'm trying to do here is I just applying this formula. So we have like del equal to 2 pi by time period into delta t. So our this is actually pi by 6. I'm just writing in the form of radian because there is pi, so it will be easily cancelled, right? If you write in form of degree, so you have to like convert into the form of radian, right? वैसे भी the SI unit of angle will be taken as a radian. So try to convert it into form of radian. So pi by 6 is equal to 2 pi by t into delta t. This is our actually phase, right? Pi to pi get cancelled. And here we will get t by 12. So this is the time. That means if our time period is given actually 4 seconds, so our time taken is nothing but 1 by 3 seconds. That means in just 1 by 3 seconds, our particle cover the half of the maximum amplitude distance. That means if I am talking about this, so we are just considering the first part. So the whole time period taken from here to here will be 4 seconds, and our particle is cover such a distance which is actually equal to a by 2 in just 1 by 3 seconds. Right? I hope it will be clear to all of you. So, okay, so that's all for today. In next class, we are actually dealing with some phasor diagram kind of thing. And mostly in this topic, we have to calculate the time period. So our main goal in this chapter is to calculate time period and the frequencies. We have to be smart in this. Okay. So this is the thing that what I am talking about. So आज हमने क्या पढ़ी? आज हमने फेज निकाला कि कहाँ कहाँ पे पार्टिकल कितने फेज एंगल के साथ होता है. एंड देन हमने ये पढ़ा कि उतने फेज एंगल कवर करने में या फिर उसको अगर एम्पलीट्यूड से कंपैरिजन करते हैं तो करने में कितने टाइम लगते हैं, राइट? सो दिस इज एक्चुअली द फॉर्मूला दैट यू हैव टू कीप इन माइंड. Actually, this is a very important formula. कि change in phase difference is actually equal to omega into change in time. Okay. Thank you.